Now, these are other associational studies, so again, we have to be very careful that they're not intervention trials, they're prospective studies in which we're just looking for associations. But here the data are really quite strong, and they're the reverse of what we would expect, and therefore they're paradoxical. And again, I emphasize, when you see a paradox, you have to take it seriously. And what this shows is that this group, this is cumulative hazard of dying from type 2, dying in people who have type 2 diabetes. And you can see that this group is doing much worse than the yellow group. So the blue group's doing much worse because they're dying quicker. And the question is, what are they eating? This is the lowest 5% of people for salt intake. So these people are restricting their salt intake. This is the group that's doing best. And notice their curves, it's stabilized quite well after 10 years. This is the group has the highest salt intake. So this is the exact reverse of what you would expect. So this is a population at high risk because they've got type 2 diabetes, and increased salt intake seem to be beneficial, those people who ate a lot of salt did much better. They could have been doing other things. Maybe these were the marathon runners, maybe they were not smokers, whatever. But in this case, it was their higher salt intake was not associated with higher mortality. And just to make sure we're absolutely up to date to the latest information, this is January 2016. Here's a study looking at people who were told to restrict their sodium intake in persons with heart failure. And that's our conventional medical advice. This is the conventional medical advice. We tell patients with heart disease, you must restrict your sodium. And that is presumably based on years of experience and clinical experience and lots of studies, and it's hard science. And if you told a patient to eat salt and they're in heart failure, you would be going against convention. You would be practicing bad medicine. And the question is, would you be helping the patients? Because that's what the key question is. And again, what we notice is there are three groups. On the left, it's death or hospitalization with heart failure. This is cardiac death, specific cardiac death, or hospitalization with heart failure. And this is time, so this is cumulative study, so this is all and more people. And then the red group is the group who were told to restrict their sodium.
So the red group, Professor, is in the first
first
graph.
Exactly correct. So that is the line that is going straight upwards. The red line, 42.3, it finishes at. And that is the group that are restricting their salt intake. The group that is not restricting their salt intake are doing better in terms of they're not dying as frequently, they're not dying from heart disease, and they're not being hospitalized. So once again, this is the converse of the conventional advice. And so one would question, if you were telling heart failure patients to restrict their sodium, are you doing the right thing? It may be conventional, but is it helping patients? And so their conclusion is that sodium restriction was associated with significantly higher risk of death or heart failure hospitalization, derived from an increase in the rate of heart failure hospitalization and a non-significant increase in the rate of cardiac death and all-cause mortality. So that group who was restricting were more likely to have to go to hospital. Conclusions, in symptomatic patients with chronic heart failure, sodium restriction may have a detrimental impact on outcome. And then they said exactly as I did, now you need a randomized clinical trial to determine whether sodium restriction actually makes patients worse. So that is how we function in medicine, and this is why we change, the knowledge changes. And it's our job to make sure that we keep up with our ideas, and we inform patients and we inform the public of what's the latest information. So then there's an editorial that goes with this article, and this is the Journal of American Cardiology, Clinics of Cardiology. And what it says, the results of this study highlight the need for further research investigating the effects of sodium restriction on heart failure physiology and outcomes. It is notable that only 145 of the 902 study patients were restricting their sodium intakes to less than 2.5 grams per day, which is what you're told to do. So this was the group who managed to restrict who did worst. Considering the challenge this restriction poses for patients, even more important to clarify whether sodium restriction is beneficial at all. And they conclude, until more data are available, however, guidelines regarding sodium intake in patients with heart failure should be taken with a grain of salt. Hope they won't take the grain with the salt, though. So again, the point is, that's what science is all about. Science is about change. And it's our responsibility to change with the data, and not to say, well, because I said that last year, I'm refused to change. And it's difficult to admit you were wrong, as I've done, but that's what we have to do. So we're now going to move to cross-sectional studies, and those are studies in which a population is studied, and what they're doing at one time is studied, and then when they die or develop disease, we try to explain that on the basis of things that we measured early on. So these studies are associational studies, and they can only prove causation under one strict criteria. Now, most nutritional studies, we look at people, what they ate 30, 40 years ago, and we try to associate with the outcomes. What I'm going to show you today is only under very strict criteria can you say there was probable causation, that the people eating the bacon for breakfast here died of a heart attack here because they ate the bacon and not because they had a cigarette with the bacon at the same time. That's the key. You have to make that distinction. And you can make it the distinction under very, very strict criteria. So having said you can't use these studies to prove association, in causation you can, but it's only under very strict criteria. And what happened was that with this flood of new studies in nutrition, we lowered the bar so far that we forgot what those criteria were. And I'm going to spend some time explaining you cannot drop the bar, because then you get the wrong conclusions. So the most famous associational study was Ansel Keys' study, in which he said that because the rates of heart disease are almost a linear function of calories from fat in the diet, that the fat is causing the heart disease. Now that is a leap of such faith that we could never accept that. And so my point was, we should never accept this, because this is an associational study. But because of the power of this man, and you can see it in his eyes, the power of this man, he managed to convince the entire world that we could accept this association as causation. And so we're going to go through what would you have to do to prove causation from an associational study. And I have shown you this, that when epidemiologists looked at it, they said there was no evidence for association. There were so many other things that might be explaining it. But unfortunately, that message never got out, even though these people wrote that in 1957, and the association was accepted as fact. Now, the man who has done most of the work in understanding when we can accept association as causal is Austin Bradford Hill. And he wrote the classic textbook in 1937. So it says here, between January and April 1937, the Lancet published a series of 17 articles on medical statistics by Austin Bradford Hill. So he became the father of epidemiology and how you use medical statistics in epidemiology. So he wrote the book in 1937, and by 1950, the first two famous studies had been done on the basis of that evidence. And the first one was a randomized controlled clinical trial of the use of streptomycin in tuberculosis meningitis. And I'll show you that study. And then that was an intervention study, so that they took people with tuberculosis, and some got the drug and others didn't. And because he randomized it, he was able to show that with time, the streptomycin stopped working as effectively, because the tuberculosis was becoming resistant. The tuberculous bacillus was becoming resistant. But because he'd randomized the study, he could prove that, which showed what a strong study it was. And then with Sir Richard Doll, he proved, and notice I put the question in details. He proved that smoking causes lung cancer, but he proved it from an associational study, which cannot prove causation. But in his case, he was able to do it. And so he wrote that series of articles in 1937. So on the left is the study of the streptomycin treatment of pulmonary tuberculosis. So that is the first randomized controlled clinical trial that I know of in medicine. There is one other on vitamin C, which was done on scurvy in 1700s, but it wasn't written up, so it didn't make the British Medical Journal. This one made the British Medical Journal. And here's the smoking and carcinoma of the lung. So these are both written by Bradford Hill as one of the key authors. And so what did he work out? He worked out that what you want to find out is that the environment, if you have a disease that is present in the environment, is it association or causation? Is the environment and what components of the environment are causing the disease, or they're simply associated? As I've said, if you have a cigarette and you eat bacon in the morning, which are you going to say is going to cause the disease? Is it the cigarettes or the bacon? And so he said these are 9 criteria for determining causality: the strength, the consistency, the temporality, the biological gradient, the plausibility, the coherence, the experiment, evidence, and the analogy. And you had to explain all 9. All 9 had to be correct for you to be certain that you're dealing with causation. And so again, the point here is that when you're dealing with multiple factors that could be causing disease, you have to fulfill all these criteria. It's not like tuberculosis and Koch, where he could identify the single factor. When there are many factors, it becomes increasingly difficult to identify which factors are causative. And so he said, here then are 9 different viewpoints from all of which we should study association before we cry causation. Understand that. You've got to fulfill those 9 criteria before you can cry causation. What I do not believe is that we can usefully lay down some hard and fast rules of evidence that must be obeyed before we accept cause and effect. None of my 9 viewpoints can bring indisputable evidence for or against the cause and effect hypothesis, and none can be required as a sine qua non. What they can do with a greater or lesser strength is to help us make up our minds on the fundamental question. And this is important. Is there any other way of explaining the set of facts before us? Is there any other answer equally or more likely than cause and effect? And this point is described again by James Lefanu, who wrote this book, The Rise and Fall of Modern Medicine. And it's quite interesting that he's predicting the fall of modern medicine. And he said the following.
Page 941, Madam Chair.
Bear in mind Sir Austin Bradford Hill's insistence that statistical inferences by themselves have no meaning unless they're internally coherent. They have to be coherent. That is to say, when several different types of evidence for an association between environment, factor, and disease are examined, they must all point to the same conclusion. If one's pointing in the wrong direction, it's not likely that we're going to talk in causation. So all his 9 points had to be pointing in absolutely the same direction, and then you could say, perhaps there's causation and it's just not associated.
Madam Chair, we move to page 9.
And sorry, put another way, no matter how plausible the link between dietary fat and heart disease might seem, just one substantial inconsistency in the statistical evidence effectively undermines it. And this Fanu wrote in that book. So this was now probably 10 years ago. He was questioning the link between dietary fat and heart disease and saying all the evidence better line up, or else we may not be explaining causation. So this is the key slide for associational evidence, and when can you assume causation and when can't you? And this helps us now to explain why every day you pick up the newspaper, and I won't say which newspaper because the journalists are in the audience, but you pick up the newspaper and you said that today bacon causes cancer and tomorrow it's broccoli causes cancer, and the next week it's something else. And the question is why? How can there be so much nonsense written every week about causation? And I'm going to explain to you, if you understand this, tomorrow when you pick up the newspaper and you see that bacon causes cancer, you'll be able to understand, okay, what facts do I need to look at in this report to be able to decide whether this is scaremongering science or it's real science? So I'm going to give you the division between scaremongering science and real science. So now the hazard ratio, as I've described, is the proportion of people who develop the condition who are in the at-risk group versus the proportion of people who are not at risk, who don't do whatever that activity is. So if you eat bacon, then you're at risk group, and we look at how many people develop cancer because in bacon eaters and in non-bacon eaters. And the hazard ratio is the difference. how many more people develop cancer from taking bacon than those who avoid it. And the first study which was reported was in 1875 by Percival Pott. And Percival Pott studied an unusual condition called scrotal cancer in chimney sweeps. And he found that scrotal cancer almost didn't exist unless you were a chimney sweep. And the hazard ratio was 2,000-fold higher in chimney sweeps than in the other people living in London. And then he was able to explain why it was, because these guys were poor and they didn't change their clothes, and so the soot accumulated in their underwear, and that caused the cancer. So we could go and look, take the soot and see, yes, that soot, when you apply it to skin for prolonged periods, it will produce cancer. So there's a plausible explanation, there's a biological explanation, there's everything there. But the hazard ratio is immense, 2,000-fold greater. So no one is ever going to say, we actually have to expose chimney sweeps to soot to see whether they develop cancer. We don't need it. We don't have to do that experiment. There's some experiments you don't have to do. You don't have to jump out of an aeroplane without a parachute to know that it's dangerous. And that's the same here. Because 99% of people who do that will die. So we don't need to do that experiment. We do not now have to do a randomized controlled clinical trial to see whether soot will cause scrotal cancer. But that is the highest relationship that ever been found. Now, Doll and Hill discovered that lung cancer in heavy smokers was 20 to 30-fold increased. Now, of course, that looks a much less, but would that be enough to prove causation? And the answer is yes. We now know through other studies that lung cancer is caused by cigarettes, and so that 20 to 30, that's fine. So in other words, if we have a hazard ratio of 22 to 30 in an associational study, we'll accept it as causation. And this was studies done by John Snow on cholera in 1849. And if you were getting your water from the Southwark and Vauxhall Company, you were at a 14-fold greater risk of dying from cholera. And that was because that water was contaminated with the cholera bacterium. So you were getting infected water. Again, explanation simple, mechanism, cause, fine. But 14-fold greater risk, again, has a very high hazard ratio. But even poor old Snow had troubles because Dr. Snow's view on cholera generally regarded in the profession as very unsound. But he was right, and cholera was a waterborne disease, and he'd proven it by epidemiological studies, and there was the evidence. So now lung cancer in all smokers is 10-fold higher, so that's still very high, but it's much less high than in heavy smokers. And then we get down to now much lower values. So now we've gone from 2,000 to 2. And the death from coronary thrombosis in smokers is about 2-fold greater than in non-smokers. And now Hill was getting a little bit twitchy because he said, I'm happy with 10, hazard ratio of 10 or 14 or 20. Those definitely prove causation. But 2, I'm not sure. That is too low to be absolutely certain that it's the cigarette smoking and it's not something else that people are doing that's causing their coronary thrombosis. Maybe they're not exercising. Maybe smokers don't exercise. Maybe smokers do something else. They drive their cars or whatever, or they're more stressed, or they're from lower socioeconomic class. It could be anything else. It couldn't just necessarily be the smoking. So he put the bar at 2, and he said if it's lower than 2, the hazard ratio cannot be interpreted to prove causation. And so therefore, we can claim that if the hazard ratio is below 2, there's no evidence for causation. And that is scaremongering science. That is the science you read every day in the newspaper. Scaremongering science. That bacon causes cancer with a hazard ratio of 1.23. That is so low, it is utterly meaningless. But the problem that's happened is the scientists will say that this is an associational study. So bacon is associated with coronary heart disease, with cancer. But then in their conclusions, they'll say people must stop eating bacon because it's causing cancer. But they didn't show that. And that's how they get it in and how we get confused. And so the public, as soon as they see association, they assume causation. And it's not that way. So that's the problem. Now, The point is, all the association nutritional studies that are used to justify the 1977 US dietary guidelines are based on studies with hazard ratios usually between 0.7 to 1.3. 0.7 means that there's a protective effect, 1.3 means an increased hazard ratio. Now, Bradford Hill would never have accepted any of these studies as evidence of causation, or to be used as the sole justification for novel global dietary guidelines. And so I put the blame for the problem that we have in our nutrition advice is that organizations like Harvard pushed this idea that the hazard ratio was unimportant. And just as long as they had a hazard ratio above 1.1 or 1.2, they said it's causation, or they implied it's causation. And that is why we read that cereals and grains are healthy. And that's from associational studies with low hazard ratios. And that's why I went through great length yesterday, saying when there are randomized controlled clinical trials, there's no evidence for benefits of cereals and grains. So if I want to present the evidence, I could just say, well, actually, let's ignore the hazard ratio story, and we'll just look at associational studies, and I'll present wads of evidence that cereals and grains are the healthiest things you can do for you in your life. And I can make an argument. And as long as people don't understand hazard ratios, they'll say, gosh, that's a great argument. I must eat cereals and grains. But on the other hand, if I say that there's no evidence for causation of good health, and if we look at the randomized controlled trials, there's no evidence, I can make the opposite argument. And that's what happened. It's precisely what happened. That we've looked at the wrong studies as the definitive evidence. And we've taken studies which are not definitive evidence as if they're definitive evidence. And that is what we teach our students. From non-definitive evidence, we tell them that these things are good for them. And we don't look at the randomized trials. And we don't look at the randomized trials because they're inconvenient and it's difficult to change. And it's difficult to say, gosh, I shouldn't have taught you all these associational studies. I should have gone to the randomized trials, but I didn't. Difficult to apologize for that. So the next paper is a systematic review of the evidence supporting a causal link between dietary factors and coronary heart disease. Now, what they did was they took all the associational studies of specific dietary factors and coronary heart disease outcomes, and they applied the Bradford Hill criteria. They applied 4 of those 9 criteria to see which of these foods would fulfill all 4 criteria. And this is what they concluded. Using those 4 Bradford Hill criteria of strength, consistency, temporality, and coherence, they found strong evidence for a protective effect against heart disease of vegetables, nuts, the Mediterranean diet, and high-quality dietary patterns. Now, the high-quality dietary patterns, to me, would be eating real foods, and maybe that wasn't, but that's how I would interpret it. So, what would you conclude about protective effects against coronary heart disease? They're all promoted by low-carbohydrate diets. Every single one of those is promoted by a low-carbohydrate diet. We promote vegetables, we promote nuts, we promote the Mediterranean diet, perhaps with the exception that we don't like all the cereals in the Mediterranean diet, and we promote high-quality, nutrient-dense foods. Harmful effects promoting heart disease. Trans fatty acids, which remember were introduced into the food chain by the processing of vegetable oils, and foods with high glycemic index or load. And those are specifically avoided on the low-carbohydrate diets. We specifically say you do not eat foods with a high glycemic load, and you don't eat trans fats. And then insufficient evidence. Saturated and polyunsaturated fatty acids, total fat, alpha-linolenic acid, meat, eggs, milk. And those are compatible with low-carbohydrate diets. There's no evidence on either way. So therefore, if you're actually to use Bradford Hill criteria for associational studies, they support the idea that low-carbohydrate diets that we're promoting are healthy and protective against heart disease. And absolutely no evidence that what we're saying is causing heart disease. And so James Lafanu has the final word on this particular point, and he very disparagingly says the following. Meanwhile, the simple expedient of closing down most university departments of epidemiology would both extinguish this endlessly fertile source of anxiety mongering while simultaneously releasing funds. So what he's saying is that until you understand epidemiology is about associational studies, and until we limit the push to make associational studies being accepted as causation, we're in trouble. And I argue that this is why we're in trouble on nutrition advice, is because we focused on the epidemiology, not on the biology, not on the randomized controlled trials. And just to, so there we go. So now if you wanted evidence that is not compatible with the diet-heart hypothesis, there's all the evidence. And so there's no internal coherence in the diet-heart hypothesis. And I'm not going to go through with it, but I'm just saying that those are 6 points that I just can easily make up in my mind that disprove the consistency of the diet-heart hypothesis. And then again, things must be logical. They must be coherent. And so the reason why we prescribe drugs that lower your blood cholesterol, the statins, was purely based on the diet-heart hypothesis. So therefore, if the diet-heart hypothesis is true, when we lower people's cholesterols, as we can very effectively with these drugs, we should be able to measure massive changes in their survival, because we've lowered the thing that's killing them. They should live forever. And the answer is, from recent studies, that if you treat people with these drugs which lower cholesterol 20 to 30%, death was postponed between -7 and 19 days, and -10 and 27 days in people with heart disease. But the median postponement of death from people who are either healthy or had heart disease, that's primary and secondary prevention trials, were 3.2 and 4.1 days respectively. So the theory is not right, because the medication which we've prescribed to attack the biology that's causing the disease in our interpretation isn't working. So we have to ask the question, well, maybe we got it all wrong. So we go back so that's the coherence and consistency. So if you have a hypothesis, you test it, it doesn't work, and it's not coherent, then it's time to move on. And so this is Bradford Hill's final statement. All scientific work is incomplete, whether it be observational or experimental. All scientific work is liable to be upset or modified by advancing knowledge. That does not confer upon us the freedom to ignore the knowledge we already have or to postpone the action that appears to demand at any given time. So what he's saying, we have to act on the basis of the best evidence we have at this time. We can't postpone the action. And my argument would be that now is the time to question the dietary guidelines. There's enough evidence to show that they're wrong. And we do not have the right and the freedom not to do something about it. We have to question, we have to change, we have to move on.